Hello and welcome to the last part of the Introduction to R video lecture for the Network Summer School 2018. In this part I want to talk about data, about indexing data and how to represent data in R. And to wrap things up and get you started. One very important function in R is the matrix function. And this is a function that we'll use a lot. This is the function that we'll use to encode a network structure and also to represent data. Technically, a matrix is a vector with simply a dimension attribute. The rows indicate horizontal lines and the columns indicate vertical lines of the cell. So if you have a matrix, rows are always horizontal, columns are always vertical. If you use the matrix function, the first argument is to fill the matrix with the vector, and then we can use the nRow and nCol argument to set the number of rows and number of columns. So this is a very simple example of a matrix. And I'll also make it here. You fill the matrix with the vector 1 to 9 with 3 rows and 3 columns. Oh. Now I have a matrix. It has the values 1 to 9 and they're filled column-wise. So it first goes the first column, then the second column, then the third column. Because nRow and nCol are the second and third argument of this function, I could also simply say 3, 3, what I did here above. And it's the same thing. So I like to write out arguments as much as I can. If I use the byRow equals true argument, I instead fill the vector by row, not by column. A useful trick I often use when I make a matrix is to write it out using spacing. So I can write values here. And in R I can just arbitrarily use spaces and new lines, it doesn't matter. So by writing out the matrix like this, I can see already what the matrix is going to look like. You need to have the number of rows and number of columns correct. So if I want to add another row here, a column here, sorry, I need to make this 4 columns. But it makes writing these matrices a lot easier and also changing them a lot easier than doing it the normal way. You can use square brackets to index matrices. I actually have not discussed this yet, but you can also use square brackets in a vector to index a vector. If I have a vector, and I make it, say, the elements 4, 5, and 6, then I can ask for R the second element of this vector, which is a 5, using square brackets with only one value. And I can override this with something else. This is actually why R shows you this bracket bomb bracket if I print anything, even a number, because a number is simply a vector of length 1. So it'll show you where the indexing starts. You make a long vector, say with 100 random numbers. It will show you that on this line here, the indexing starts at 6, 11, and 16. In the matrix, I can use the same notation, but then use a comma to separate between row and column. So this will tell me I want the element from row 1 and column 3. That will give me 3. Now I can override this element too. Now I overwrote this element here in row 1, column 3. If I want to get an entire column, I simply can omit anything here in the row part. If I want to omit an entire obtain an entire row, I can do the same thing. Again, R already tells you this by printing out these brackets with the comma notation to show you that this is column 3, this is row 1. You can get the number of rows, the number of columns of a matrix in R using the nRow and the nCol functions. Now a more tricky data object is called a list. And a list in R is a very flexible vector that you can use to store anything. I always make the comparison to a thing on which you can hang coats, but also like jackets or umbrellas or anything you want. So here I make a vector, then I make a matrix, and I put them both in a list. Now I have a list. It has two elements. The first one is my long vector. The second one is my matrix. I can name them as well. Say name1 equals this. Name2 equals that. And now you can see here that it says that they are named. I can use the str function on a list to obtain the structure of a list, to see what's in there. To index a list, I can use the $ notation if they're named. And in RStudio will already give me the names I can use. That's really nice. To get the element called name1 or name2. I can also use this double bracket notation to get the first element or the second element. It's important that you use double brackets, not single brackets, because single brackets is always a subset of a vector, and in this case that would give you a list still, so it's hard to work with. So you have to use double brackets, not single brackets. These are really useful objects, and or many advanced R functions will output a list for you that has a lot of objects stored in it. For example, the QGraph object will return a list that has all information about the node placements and the color and the lines and the thickness of edges, etc. stored in there somewhere. Now the most important and final object is the data frame. And the data frame is sort of the child of a list and a matrix. The data frame is a list that thinks it's a matrix. The data frame is the way you will represent your data. And your data might consist of objects of different types, like numbers, but also characters, like male, female. The data frame works and acts like a list, but the only difference is that every object has to be a vector of the same length. And then it will represent them as a matrix. So I can write data frame. Then for example I can score equals some value. And a second I can have some gender. And now if I print this, I have both scores and genders. Whenever you make a data frame yourself, you might want to say strings as vectors equals false, because R likes to work with a data type called a factor. It goes beyond what we use this week, and it's not really needed as well. So this allows us to represent data, and this is the way your data is usually imported into R. If you read an SPSS file into R, you will get it as a data frame. I can index this in the same way I can index a data frame, a matrix, but also in the same way I can index a list. It's very useful. This is also an example of how I can put different types into one big data frame. And as I showed, I can index them in multiple ways. Now importing data in R is now much more easy than it was before, because RStudio has this file, import dataset tab, and then you can import data from different sources. It will give you the codes that you need to use to import your datasets. So you can try this first, and I will not discuss in more detail how to read data now. And the final thing I want to show is how to compute a correlation matrix. It's a very important function for this course. And we can simply use the COF or the core function for that on a matrix. So here I have a matrix with two numeric values. If I use core on that, it will give me a correlation matrix I can use to compute a network with. Missing data, I already showed you, is encoded in R with the NA or not available sign. And if you have missing data, you need to handle that in some way. Usually functions already have a default way of handling it, but sometimes they don't. And it's very important to realize that having NAs might create some problems. You also want to check the help files for that, because it really depends on each function how to handle it. For example, the core function, you have to say use equals pairwise complete observations, to use the pairwise observations to compute the correlation. But in the mean function, you have to say na.rm equals true to remove NAs. You can also use the NA omit. That will simply remove every row in your data frame that has an NA in there, the list-wise deletion. Now that's it for the introduction lecture. There's this very nice, very short introduction to R available online. I will put the link to this also below this video. And I can highly recommend you to work through this file, which will give you the basics of RStudio and R. For the summer school, you can skip the part on programming, although I can recommend to read it nonetheless because it's very insightful. Alright, thank you, and I look forward to seeing you in Amsterdam in a month.